7.3 is going to be a t-test. And the reason that it's a t-test is because we do not know population standard deviation. Now, what they are going to probably give us is the sample standard deviation. I really don't remember. Let me look down here. Yes. So what you will be given, let's change colors. You will be given the sample mean and the sample standard deviation. Now, the problem with that is that it's not always real clear. So you have to look very carefully and make sure you are not seeing population standard deviation. If you see population standard deviation, you go back and do a z-test. But if you do not see population standard deviation, then you're going to be doing a t-test. I'm going to be using the table and probably StatCrunch. I'll do a separate video that will show the calculators. Let's read the problem. A used car dealer says that the mean price, he's saying, so in other words, the dealer says this right here is the claim. The dealer claims, okay? So the claim in the first part of the sentence is that the mean price of used cars sold in the last 12 months is at least. Now, what does at least mean? Okay, at least. At least means that it's gonna be this, but it's okay if it's more. At least means 21,000 or more. That's what at least means in this case. At least 21,000. It means it's going to be $21,000 or more. So that means that we're going to do greater than or equal to 21,000. Okay. Now, our claim contains equality. So we're going to call that H sub O. The opposite of being at least 21,000, the opposite of being greater than or equal to is being less than 21,000. And that, since it does not contain equality, that is our alternative hypothesis. All right, we suspect that the claim is incorrect and find a random sample of 14. So if 14 is our sample size, that's not big enough. It's supposed to be 30. What must we also know? The population is normally distributed. Okay, so we're okay with that small sample size. So you suspect it's incorrect. 14 cars sold in the last 12 months. You found that the sample, these 14 cars, they had a mean of a selling price of $19,189 and a standard deviation. Now, see how it just says standard deviation? It doesn't say population standard deviation. And if you pay attention to the sentence structure, then you see right here that it says the random sample of 14 cars has a mean of this and a standard deviation of this. So this standard deviation right here is still talking about that sample. So that's the letter S that we use, and it is 2950. Okay, is there enough evidence to reject the claim? There's your alpha. Okay, now you can do this by hand. I'm going to need to give you the formula sheet. I can't believe I didn't put it on here. But let me give you the formula sheet real quick. There it is. So here's the population mean right here. You find the test statistic. There's the formula for the test statistic. You find the value of t, and like I said, you can calculate it by hand. So t is equal to x bar minus mu divided by s divided by the square root of n. Let me go back and make sure that was right. There it was. S divided by the square root of n. Okay, so x bar minus mu divided by s divided by the square root of n. So you can do that by hand and find that t value. You can also, you're also going to want, if you do this by rejection regions, to do rejection regions, which you should know how to do. If you do the rejection region, then you're going to need to remember, let's see, what is this? What kind of test is this? It's less than, so it's a left tail test. So we've got shading over here, and we need that critical value right there. Okay, so we've got this part right here is shaded, but we need this critical value, because in order to have a rejection region, you have to have a critical value, and then you have to have a test statistic. So we can calculate the test statistic, but in order to figure out, you know, where its placement is going to be, we've got to know where this critical value is. What's the t-score for the critical value? So we're still dealing with alpha. Alpha is an area, okay? And so we have an area here, and we need to find a critical value for that area. And I think we'll need to use a t-chart for that. I'm going to go ahead, because I don't have the t-chart pulled up, so I'm going to stop this video. I'll get the t-chart pulled up, and then we'll start here on the next one.